Hello and welcome to Physics Teacher. In this grade 12 chemistry tutorial, I'm going to show you how to balance redox reactions. Now I'm going to do this with two different methods. The first method is the oxidation method, and I'll show you that method using both an acidic solution and a basic solution. And then the third example is I'm going to show you how to balance redox reactions with the half reaction method. So let's start with our first example. This is an acidic solution, and we are going to follow this step process. So the first one says assign oxidation numbers and identify the changes. So how do we assign oxidation numbers? Well, first, hydrogen will always be +1, okay, except in hydrides. And oxygen will always be -2, except in peroxides. If there's anything like monatomic ions, like this silver right here, you just need to look at the charge on the ion. So in this case, the charge is +1. Also, if there's any atoms in element form, like for example, this silver right here, that's just a charge of 0. All right, so I've assigned charges to both silvers. Let's do the same thing for nitrogen. So this oxygen has a charge of -2. And we have 3 of them. So that's a total of -6. Now the overall charge for the molecule is -1. So that means this nitrogen would have to have a charge of +5 in order for that to be true. Why is that? Well, let's look at this for a second. We have 1 nitrogen. So 1 nitrogen gives us a charge of +5. And each oxygen has a charge of -2. And we have 3 of them, so let's multiply that by 3. This gives us a charge of +5 and -6, which is a total of -1, which is what we have right here. So that's how we determine nitrogen has a charge of +5. All right, lastly, we have nitrogen over here in the reactants. So this oxygen is -2. And since this molecule has no charge, it means the nitrogen is also +2. All right, next, balance any elements other than hydrogen and oxygen. All right, so we have 1 silver and 1 silver, so that's fine. 1 nitrogen and 1 nitrogen, so that's fine. In the next example, I'll show you where it's not fine. But for this example, it's an easy start, it's fine. All right, step number 2. Determine the total number of electrons transferred per reactant. All right, so let's start with silver. Has silver lost or gained electrons? So it went from a 0 to a positive charge. This is quite confusing. It makes it look like you added, right? Because 0 to +1, oh, well, that's adding. But remember, we're talking about the addition or subtraction of electrons, and electrons have negative charges. So for example, let's say we had this object. An object, if it has no charge, that doesn't mean there are no charges present, it's just the number of positives and negatives are equal. So this is an object with a neutral charge. Now if we were to end up with some sort of positive charge, that would mean 1 electron would have to leave. And now we have an overall +1 charge. So we lost an electron in this case. So this is, we lose 1 electron. So in this case, silver is being oxidized. If you remember the acronym or mnemonic, if you lose electrons, you're oxidized. If you gain electrons, you're reduced. All right, so let's look at what's next. Nitrogen. What's happening to nitrogen here? We are going from a charge of +5 to +2. So it looks like we're losing because we're going +5 down to +2. But again, same situation. These are negative electrons. So what we're doing is we're actually gaining, and in this case, 3 electrons. All right, so we've determined all about our electron transfer. The next step is to balance that electron transfer. This isn't balanced right now, right? We have to lose and gain the same amount of electrons because charge must be conserved. So if we gain 3 electrons, we should lose 3 electrons as well. So to balance this, I'm going to multiply both by the lowest common multiple. So I'm going to multiply this by 3. And we're going to multiply this by 1. So we're going to multiply, so we're going to put 1s here. We don't really need to put 1s, but I'll show it. And then over here, 3. Like so. Okay, let me rewrite this equation because it's gotten a little bit messy. So let's rewrite what we have so far. All right, so I've got it rewritten. Now we're going to go on to step 4. Balance oxygen by adding water. So let's count our oxygens now. Over in our reactants, it looks like we have 3 oxygens. And over in our products, we only have 1 oxygen. So we need 2 more oxygens. But unlike for just a regular chemical equation where we would balance the elements by adding coefficients, we're not going to add a coefficient here. What we're going to do is add water. So since I need 2 more oxygens, I'm going to add 2 water molecules. Okay, so now you've probably realized there's a problem. Hydrogen has just been added into the equation, so it's not balanced. So what are we going to do? We're going to balance hydrogen by adding hydrogen ions. Okay, now this is an acidic solution, so we've got 4 hydrogens in our products. So let's add 4 hydrogen ions into our reactants. And now you have a completed balanced redox reaction. Now there's some extra steps for basic solutions, so why don't we take a look at an example of a basic solution. All right, so here's our next example. So let's start from step 1. Assign oxidation numbers and identify the changes. Okay, so let's start with manganese here. So oxygen, there's 4 of them, and each one has a charge of -2. So 4 of them would give us a charge of -8. Now the total molecule has a charge of -1. So manganese must be +7. Okay, so I know this part is again tricky. I have a lot of students that have trouble with this. So think of it again this way. What number for manganese do we need for the charge if we subtract a charge of 8 gives us a total charge of -1? Okay, so that must be 7, +7. Okay, now here we just have a charge iodine ion of -1. This one we have -4. So each oxygen will be -2. And again, if we're thinking of it like this, what charge for manganese subtract 4 must give us a total charge of 0. And so in this case, our answer is going to be +4. And then iodine over here on its own has a charge of 0. All right, so let's see what's happening to these charges. But first, I told you we're going to do an example where we are going to actually need to balance those elements other than hydrogen and oxygen. So manganese has 1 here in our reactants and 1 here in our products. Iodine, however, has 1 in our reactants and 2 in our products. So just as we would do balancing regular chemical equations, we're going to change the coefficient here to a 2. But now this makes step number 2 a little bit more interesting. So it says determine the total number of electrons transferred per reactant. Let's start with manganese. Nothing too interesting here, but let's start with this one. So we go from +7 to +4. So in this case, we are gaining. We are gaining 3 electrons. Think of it as gaining 3 negative integers. Okay, so that drops us down from +7 to +4. Okay, nothing too interesting there. And if we're gaining electrons, that means manganese is being reduced. Iodine, however, goes from -1 to 0. So it is actually losing electrons. And because it's losing electrons, it's being oxidized. But how many? Here's the important thing. Total. Okay, it looks like from -1 to 0, we are losing 1 electron. However, we have 2 of them. Okay, so we're going to have to multiply that by 2. So we are losing, essentially, 2 electrons. Okay, that was the tricky thing there. And now, moving on to step 3, we need to balance that electron transfer. If we're gaining 3, we should be losing 3, not 2. We need to gain and lose the same amount. So let's look for the lowest common multiple, which will be 6. And so we're just going to multiply this one by 2 and multiply this one by 3. Right? So let's put in 2's in front of both of our manganese. And we'll put a 3 in front of iodine. And what about here? Well, since we're multiplying by 3, essentially all the other ones just had a 1, but this one has a 2. So that is going to be 2 times 3, which becomes now a 6. So this is getting a little messy, so let's rewrite this and then we'll move on to step 4. All right, so here's our equation. And moving on to the next step, we need to balance oxygen by adding water. Okay, so let's check out all of our oxygens. In our reactants, it looks like we have 4 times 2, so we have 8 oxygens. So we have 8 oxygens in our reactions. And in our products, we have 2 times 2, which is 4 oxygens. Okay, so we need 4 more in our products, so let's add 4 water molecules. And then hydrogen becomes the issue. So we have 8 hydrogens over here. So let's add, doing step 5, we're going to add 8 hydrogen ions. Okay, now for basic solutions, moving on to step 6, we need to add hydroxide ions to both sides equal to the number of hydrogen. So here we had 8 hydrogen. So now I'm going to need to add 8 hydroxide as well. And we need to do that to both sides of our equation. Okay, and then finally, we're getting there. Running out of colors. It's all right. Step 7, combine them to form water. So here we have 8 hydroxides and 8 hydrogens. That's going to form 8 water molecules. And then cancel the same number of water on both sides. So here I have 4 water molecules and here I have 8. So I can cancel 4 on each side, which leaves us with 4 on the one side. So let's rewrite this all now. So we've got 4 water molecules plus we have 2 MnO4 negative plus 6 I negative is giving us 2 manganese dioxide plus 3 iodine plus 8 hydroxide ions. And now we have balanced our redox reaction for a basic solution. Alright, next, what I'd like to do next is go back to our first example. I want to do this exact same example, but I want to show you a different way of balancing it. So we're going to balance it not with oxidation numbers, but with half reactions. Alright, so here's the same reaction from the first example, but we have new steps. Okay, 6 and 7 are actually the same. For a basic solution, you do the same steps once you're done with the first set of steps. So the first step is to take that skeleton equation and split it into 2 half reactions. So one half is going to be with silver. So let's write that down. So we have Ag as a solid, giving us Ag plus. as our aqueous ion. Okay, and the next one is going to be with NO3 and NO. So we've got NO3 coming over to give us NO. Now these two equations look a lot simpler. So step 2 is to balance each half reaction. All right, the first one looks pretty good. We have 1 silver coming to 1 silver. The charges is off. So what we're going to do, and this is going to be different from before, is since charge is not balanced, I'm going to add electrons to balance the charges. So here we have in our reactants total charge of 0, and in our products a total charge of +1. So to make sure it equals 0, I'm going to add 1 electron. All right, so now that one's balanced. Now, for our second equation, or our second half reaction, a nitrogen is balanced. Oxygen is not. So we're going to balance oxygen the same way we did before by adding water molecules. So we have 3 in our reactants and 1 in our products. So let's add 2 water molecules, so 2 H2O. And now we have to balance hydrogen. We're going to do that the exact same way. So we have 4 in our products, so let's add 4 hydrogen ions into our reactants. Okay, so we've balanced the nitrogens, we've balanced the oxygens, and we've balanced the hydrogens. Next, we need to balance charge. Okay, so in our products, it looks like we have a total charge of 0. And in our reactants, we have 4 positive charges. So we have 4 positive charges and 1 negative charge. So that's a total charge of 3 positive. But I want it to equal 0 because we don't have any charges over here. So since we have 3 positives, what I'm going to do then is I'm going to add 3 electrons to balance those charges. All right, so now we have our 2 half reactions and both of them are balanced. Moving on to step 3. Multiply each half reaction by simple whole numbers to balance the electrons lost and gained. This goes back to our previous strategies. We had to make sure that the same number of electrons that were lost are also gained. So we can see right here in our products we have 1 electron, but in our other equation we have 3 electrons in the reactants. Those aren't equal. So what I need to do is make them equal. So I can multiply equation 1 by 3 to do that. So the whole equation, don't just change the number of electrons to 3, multiply the whole equation by 3. So we're going to have 3 here, 3 here, and 3 here. All right, so that's step 3. Moving on to step 4, we're going to add the 2 half equations, canceling the electrons. And that's what we really wanted. That was the purpose of step 3, so that when we take equation 1 and add to equation 2, we have the same number of electrons in our reactants as our products so that they cancel. So let's just write down everything else we have then. Okay, so we have 3 silvers, 4 hydrogen ions, we have an NO3 ion, and then in our products we have 3 silver ions, we have an NO, and we have 2 water molecules. Now the cool thing is if you go back and look at the answer we did for the first example, it's the exact same thing. So 2 different strategies to balance the equations, and if you wanted to use the half reaction method for a base, no problem. From this point on, you still follow the same steps 6 and 7 to do that. I hope this tutorial helped. If you have any questions, let me know in the comments, and if you haven't already, please subscribe. Thank you.